Welcome to this developer recap of the 3rd of February. Small agenda. I'll share some stuff about the Hazelnut release, what we fixed and what we have added. Carl will give you a demo on the internal API security feature that's being added for the next version. Stephen will do a presentation on the new Secret Store API and on the authorization request working group. And I'll finish up with the multiple vendor working group progress. So for the next release, we focused on results from the penetration test and fixing some things that we assessed during our threat modeling sessions. So we have threat modeling sessions scheduled for each week, where we try to find stuff that potentially can harm the node. And of course, we added some small features and various bug fixes, although all the bug fixes should be in the current version as well. So, penetration test results. We did not fix all the things that were mentioned because some of them are pretty hard to fix. Also because we're depending on other libraries, like standard libraries or other services. For example, the Vault Key Value Store did a similar penetration test, and they also mentioned that some of the issues found cannot be fixed or won't be fixed. So the things we changed is it's no longer possible to pass secrets through the command line interface, because they will show up in your overview of processes, and then any administrator can actually read what the secret is. So secret passing can only be done through the configuration file or through environment variables. And I think environment variables are the preferred way of doing it. We added audit logging on every private key operation. So that's signing, key rotation, basically every DID document change and verifiable credential issuance and revocation are now logged in the log file, and they're tagged as audit log. We changed default file system permissions, and they are less open. We prevent metric flooding. This was a result of recording all the API paths, so the request paths, HTTP request paths, and add metrics for it. And now they're reduced. The biggest change in this version is that strict mode is now on by default. And this does not harm your acceptance or production nodes, but your development nodes will probably not start up if you update to this version, because you have to add strict mode is false to reuse the same configuration. One of the results of the pen test also mentions that the default key storage is set to file system, and that the file storage in general is not safe enough. I think Stephen will probably tell you more about that and the other options we're going to add, so you don't have to use file storage, at least not for production or acceptance. Okay, so the assessed threats we fixed that came out of our threat modeling sessions. Main one is API security. There is an option to secure your APIs, but we added another option. Carl is going to give you a demo on that. And future releases might require to enable API security by default. So keep your eyes on the next releases. We added audit logs on the API calls. We sanitized error returns. So there's a difference in calling an API incorrectly in development or production. So in development, you still get feedback on what you did wrong, but in production, you will no longer get any feedback, especially regarding to access token creation. You will just get a access denied or incorrect request. And we're changing the way you're authenticated to the Bootstrap node. Currently, if you configure the Bootstrap node, your node automatically accepts the node DID from the other node, and that will be no longer the case. So the other node still has to authenticate. So Bootstrap node will only be the first nodes to find and will no longer be automatically authenticated. Features, there's one feature to mention. Currently at startup, the node is searching for any nutscom address and tries to connect with those nodes. The new feature will automatically do this runtime. So any DID document change where the nutscom address has changed will automatically be picked up, and connections will be made or broken when needed. And that's it for the version 5.1, codename Hazelnut. I think we can now head over to Carl, who has a demonstration on the API security.
Yeah, can you bring up the video from the Slack channel?
Yes, I can.
And
What?
I think I can just do a quick introduction over what the idea of the feature is, and then we can play the video and I'll notate what's happening. So we're building up an IAM feature for the APIs, the HTTP APIs in the Nuts node. This is built on the concept of utilizing as much as possible features from the SSH ecosystem, because developers are quite used to it, sysadmins are quite used to it, and of course it also has a lot of stability and security already built in from the communities around that technology. So the idea is that we're passing JOTs, JSON Web Tokens, as a form of bearer token in requests. Those JSON Web Tokens are generated using SSH keys, whether they be file-based or loaded into some kind of SSH agent. We use the signing mechanism of SSH to sign those tokens, and then they're passed as a header in the requests. And on the server side, we use an authorized keys file to determine which of those tokens will be valid. And there's even some less commonly used features of authorized keys that actually allow us to do some sort of role-based things. So yeah, let's play the video here. There's a console at the top that's not showing us the bar. Okay. Is there any way to get it to show not full screen? Okay, so this is authorized keys file, which is at the server side. Now you see the server starting up. And now this is going over to sort of the client side. So you can see that I have a key loaded into the SSH agent here. We're going to use that to generate a token. So this is our new tool, the Nuts Jot Generator. You can find this on our GitHub. And in this case, we're creating a token which should be valid for Nuts Foundation node 001. Is the host name of the server side. You can see the token there stored in an environment variable. And now making a call with curl using that in a header. So you can see that we got a 200 OK, and you can also see the header that was passed in with curl. So now I'm changing the header to invalidate the token. See, we get a 401. Although I think that should be perhaps 403. We can talk about that. And now showing what happens if you don't pass that header at all. Again, unauthorized. And now there's an option in the JOT generator where you can choose the duration of it. So in this case, we're creating a token valid for 5 seconds, which by the time we submit it, it will already have expired. And again, unauthorized. So now switching over to the console output, the log from the server side, you can see EXP not satisfied, which means that the token had expired by the time it was submitted. You can see the beginnings of an audit trail up here, the username that was authenticated for that request. And also below, you can see failed to find a valid token in any location of the request, which means essentially that no token was submitted at all. And here's just the help output for the token generator that we have.
Hey, thank you, Carl. I have one question. This demo shows the perspective from, let's say, a DevOps person. How would it function for the actual application talking to the Nuts node?
Yeah, we have some options for that. We can have a configurable maximum length of the tokens. So if we wanted, we could actually set it up just to configure a long living token and embed that in the configuration of an application as a secret or something. Applications, depending on the level of complexity, could potentially use actually the JOT generator that would call out to it. They could reuse the code from the JOT generator, effectively using it as a library, where they're generating their own tokens to be passed into it, into their requests from either the SSH agent, if they say that would be probably a developer developing application, or a pretty sophisticated runtime for a service, or for a more simple approach for a service, they could choose to have either an unprotected key file that they generate tokens from, or they could have perhaps for some reason in a system it makes sense to have a protected key file where maybe the admin were to actually type in the password on system startup or something like that. So there's a number of options. Essentially, we have all the flexibility that comes with the SSH ecosystem. And it's in case there's any confusion, it's important to note that the SSH protocol itself is not used in any way here. It's the key management and crypto engine of SSH that we're utilizing. The actual SSH code here comes from the Golang X crypto package, so it's something that is likely to become part of the standard library in the future. Yeah, I think, does that cover your question?
Yeah, so basically the root mechanism for creating the tokens is just public-private key pairs.
Yeah, packaged into a very easy to use format.
So we're aiming for developer happiness, good security, and still easy to implement by applications.
Yeah, and because we're using the SSH packaging of keys here, this also gives us the ability to utilize hardware security modules, say hardware tokens that implement some kind of SSH agent integration. So one of the main things that comes to mind is say any smart card that supports the GPG SSH keys. Those will be able to be used here. And I used an RSA key in the demo video. Other key types will work as well.
Okay, thank you. I think we can go to the next subject. on the agenda, Steven?
Yes, that would be me. Let's see if I can share my screen. So, this 5.1 release is has a high focus on keeping on secrets and security. So this topic is about keeping secrets as secrets. So how to support the multiple secret stores in the Nuts node, because currently, yeah, let's see what secrets are we talking about. Well, we're mainly talking about private keys. Private keys are very important in the Nuts node because the ownership of a private key proves the ownership of the digital identity in the Nuts network, also known in the Nuts network as the DID. Those identities are based on the public key of public-private key pair, and by signing initial transaction or key rotations with the private key, you show the ownership of it. So only the node with the private key can act in behalf of this identity. And also it lets you make assertions about others, and you can present assertions about yourself to others. So bottom line is the private keys are the most important thing if you look at identity protection. So they should be stored at a very secret place or safe place. We have a few guidelines in which we develop things and design things. So the Nut Foundation advocates the highest security practices. So that's on a principle level, but in practice we also want to facilitate the Nuts node user. So the developers should have an easy to develop environment on their local machine, but DevOps, when things are going into production, they want to integrate with their available storage of choice. And at the other hand, we also have the Nuts developers who want to have a clean code base, only want to maintain code they can actually test and understand. And we want also to let others to contribute. So these are the things we should consider thinking about a solution for keeping secrets secret. So if we look at the ops part, there are many secret stores you can integrate with. Currently, we support the HashiCorp Vault because that's something we can actually test. It's an open source package you can just run on your own machine. So that's the reason why we currently support it. But there are, of course, many other cloud-based solutions like the Microsoft Azure Key Vault, AWS, the Google Cloud Platform has several. So there are many, even we perhaps don't know about secret stores a Nuts node user wants to integrate with and store their secrets in. So the question is how to support them or potentially support them all. So we have a few solutions which we thought about, and I want to quickly run with you through them. So we can, for example, include all the SDKs into the Nuts node. Currently, we have the SDK of the HashiCorp Vault into the Nuts node. But if you think of the considerations in the beginning of the presentation, there are a few downsides of this, because, well, the SDKs can pollute the code base, and we as Nuts developers cannot test them all. So we ship code which is not actually tested, and it's a fingers crossed situation. So this is not a preferred solution. And what if possible solution number 2 is we abstract the secret. We abstract the secret interaction into an API specification. So what we do is we make a very simple API specification and let the Nuts node interact with whatever secret store also implements this API specification. and everybody can generate and build a simple server to connect the secret store to the Nuts node. So it's a sort of proxy or a connector. There are no SDKs in the Nuts node. We, as the Nuts developers, ship what we can test and understand. And for the DevOps, it's a secret store workflow they already understand and use. So if you have already backups and a workflow on that, you can reuse that. But there's also some downsides, of course. You have to need to deploy an extra proxy or connector, and there might be some extra complexity when you have to communicate with maintainers of these code bases about version changes. And the third option we thought about was just keep it simple, make a encrypted file storage backend. And here are a few points. I won't go over them, but the main downside is, of course, that it's still on the disk, and it's still it doesn't integrate with all the existing key stores. So we decided for option number 2, and we designed a secret store API abstraction. So how it looks as an architecture currently is there is a secret store interface in the Nuts node. We've got a file system secret store still in place. So for local development, you can still use the file system store, which is insecure. And we've introduced an external store which implements the API, an API client, and it uses it connects to the connector. The connector you feed a config file to, and it connects to whatever store you would like. So this connector implements the SDKs of the store of choice. So the API specification is available, of course, in OpenAPI format, also known as the Swagger format. There are also automated tests. So if you decide to implement your own secret store connector, then you can use this one to test if your integration is up to the spec. So if you want to, build your own connector, we encourage that. You have to generate a server from the API specification. You can do this in your language of choice. You include your SDK of your favorite secret store, and then you have to map, of course. So these endpoints are quite simple, as you can see. You get secrets, you store secrets. It's built like a key value store, and then so you have to make a mapping. You can run provide integration tests, which is just a Docker container which you point to an endpoint of your newly built connector. Use it and provide some feedback to our team, because we are very curious if this is sufficient, if this the mapping of the API we made, if it's mappable to your store of choice. And perhaps you can publish your connector as an open source package, so other people can use it. I know for a fact that there are a lot of Azure deployments in our network, so perhaps an Azure secret store would be very nice. Currently in Nuts node, there is an HashiCorp Vault SDK into it. We want to provide this support for Vault, but we are removing the embedded support into a new, we call it a HashiCorp Vault proxy. Currently we're in 5.1. We introduced this feature as experimental. In v6, the Vault support will be deprecated, and it will probably be removed in version 7 if everything is going according to plan. So if you start using 5.1 and you want to use the HashiCorp Vault proxy in development, you can download the Docker images, test it out, and provide some feedback. So it's, except from running as the connector, it's not very difficult to migrate. Instead of, if you're currently using used file system storage, you say storage will be external, and you point it into the right URL. And if you want to migrate keys, because if they're in the file system, they have to, of course, import the keys into your new secret store. There's a command line command, which is like, for example, file system to external, and it will move all the keys or copy all the keys into the new secret store. And then it's, of course, advised to remove the secret store, the file system backups, and potentially rotate all the keys. So then you know that you are safe. So that's it.
Okay, thank you. The next subject is also for you, Steven.
Oh yeah, can you share the presentation? Your presentation.
Yes. Did you add something to my presentation?
Yes, I add something to the presentation. I think it's the last sheet. Yes. So completely different subject, still the same pace. This is about our working groups. We started a few weeks ago. There are 2 working groups. One is about multiple vendors for care providers. So I will tell you about that in a minute. The other one is authorization, consent, and authorization and consent workflows work group. So the idea is this is a very important subject about how to get consent and register consent in your nodes and use it in order to get a authorization for another party in the NUTS network, so probably care provider. So this is a very broad topic. Last week we had the first scope meeting, and we're still looking a bit for what's in scope, what's out of scope. But because it's such a broad topic, we generally want to facilitate for a few stakeholders a few things. So I will list them. So there are, of course, use case designers like VIP programs or local exchanges, and they're all always struggling with what kind of questions we have to ask, what kind of workflows are available. So who is the initiator of a authorization? Is it the party sending, for example, an overdraft, or is it the party who wants to view data from another care provider? Is the patient sitting there? Is the patient not actually available? Is there already a consent, and where is it? So all those questions makes it difficult for use case designers to answer. So we want to facilitate them in some way by making building blocks. We want to facilitate caregivers in asking and registering consent a few times as possible. Data custodians, so care providers, they have still a responsibility to, if they think that a consent request or an authorization request, for example, may harm the patient or somebody in the environment of the patient, to deny it. So we also want to facilitate them to review certain requests. Patients, of course, have a very important stake in this system. So patients want to have freedom of choice, want to have clear questions, and also want to have a insight in what consent is given where. And software builders, of course, want to have easy tools and reuse things they build from one use case into another. So as you can see, this can become as big as we want, but of course we also want to make progress. So if you want to see our scope meeting back, there's a YouTube link in the presentation. I think the presentation will be shared. I'm not sure. Otherwise, we will put it in the description of this video. We need some more participants currently because this is such a broad topic. We would like also some people from programs who already struggled with this. for use case designers, and we need to see if we can get people on board from consent solutions, for example, the MIDs, or at least to have some feedback from them. We have a Slack channel currently. It's called Workgroup Consent and Authorization. So if you want to join the conversation there, look it up. And next steps are creating a simple, fictional, or simplified use case and work out the requirements. So let's take a look at all the stakeholders and how they have to interact with this very simple use case, and then build out what we need. So that's
Great.
it. Yeah.
Yep, I shall continue with an update on the other working group, multiple vendor working group, or should we say work group? Well, anyway, we also have a Slack channel which still uses the Dutch werkgroep multiple vendor name. We have a live meeting planned next Wednesday, I guess. Is 10 o'clock in Utrecht. There are 2 places left. Currently have a group of 4 people, 3 different vendors, and somebody from the Nets community. And we have a scope session recorded. All the recorded sessions from the Nets community are placed in different lists in the Nets YouTube channel. So you can just subscribe to any of those lists and then get all the videos you want. We did a scope session as well. Some interesting results. Really, the multiple vendor working group is focused on how to reuse data or any use case that involves multiple vendors. Currently, use cases have focused on that the use case at any site for any care organization uses a single vendor to, for example, provide data, create authorization credentials, or to consume data. But of course, in the real world, this might be split up over all kinds of different vendors, all doing a small part. And of course, if you look into how these use cases are organized, it's the care organization that actually hands out the authorization. And the care organization has multiple vendors, but what it wants is just to do this once and that issue this authorization, and then it should be usable by all the other vendors of the other organization and retrieve data from all the vendors of that care organization. So that's basically the scope. But there are some interesting things that came up in the scope discussion. Like, are all vendors created equally? So does a care organization want to appoint a single vendor that hands out authorizations for a certain use case? Or can any vendor do that? Or may a vendor only consume certain data? Is it only a viewer? So it should only use authorizations and should not be able to issue them. So there's a trust relation or trust question between all the different vendors in the context of a single care organization. And we're going to look into that in the next meeting. Also, that in bigger national programs, it's the combination of vendor and care organization, saying this correctly. No, it's the combination of different vendors working together that are qualified. So if you have multiple vendors in a single use case, you get this Cartesian product of everybody that has to be qualified. Or can we qualify a combination of vendors for a certain use case, which is currently not possible for NICTIS to do that. So we might have to address them and say, okay, we should be able to qualify a combination of vendors for a certain use case. That's something we have to figure out as well. So apart from the technical and logical implementation of how we're going to solve this, there are some trust and organization problems as well. So I think that's the basic updates. Hopefully we can give an update in the next meeting on the results of that live session. And I believe this was also the last point on the agenda. So I can say thank you all for watching.